Hello! If you are watching this video, you are the person in your group that will be learning about parallel lines. So when you leave class today, the goal is that you can identify from equations and graphs whether or not two lines are parallel, perpendicular, or neither. So like I said, in class, you're going to be working with a partner today. One of you is watching a video on parallel lines, and one of you is watching a video on perpendicular lines. So this video is about parallel lines, so make sure that is the note sheet that you have with you. So let's review what parallel lines are. They are lines that have the exact same slope, or m, which is what we're used to seeing in our equations. So they have to be exactly the same. So like in the example here on our graph, you can see that the slope of both equations here is a positive 2/3. So those are parallel lines. Okay, so a couple things that we have to practice. The first thing is recognizing parallel lines from an equation. So the biggest thing you want to remember is that you're checking the slope, and that if it is exactly the same, then it is parallel. So this top equation, y equals -1/2 x plus 4, I can see that my slope is -1/2. Now in that second equation, x plus 2y is equal to -4, I don't know my slope yet because I need to solve for y. So to do that, I would need to subtract x. So we always want to get y by itself when we're checking this. And then I have to divide by 2. So that leaves me with y is equal to -2, and that's going to be -1/2 x. So I can see the slope of this one now is right there. The number with x, they're both -1/2, so yes, these are parallel. I'm going to run out of room here. Hopefully you have more room on your sheet. So let's write yes, parallel. Alright, let's check our next one. Again, I can see my slope in y equals 3x minus 2. It's the number with x, so slope is 3. I'm going to check my second one. I'm going to solve for my y again, because it's not by itself, so I'm going to distribute that. I get y minus 8 is equal to -3x minus 3, and I have to add 8 to both sides. So they're both in slope-intercept form now. I can see the second equation is y is equal to -3x plus 5. And I can see my slope now is -3. So one of the slopes is 3 and one is -3. They are not the same. So this fails. These are not parallel. Alright, we can do the same from a graph below. From a graph, it's pretty quick. We just need to find the slope of each line to see if it's the same. My word of warning always is don't assume by looking at it that it's parallel. Make sure you actually check. So for the one on the left, the top line, I would have to go up 1, and then it looks like over 2, so my slope of that one is 1/2. Looking at the bottom line, I have to go up 2, and bear with me, it's a little hard on the iPad. Then I have to go over 1, 2, 3, 4. So my slope is 2/4, which I should simplify to 1/2. So they are the same. So this is also parallel. They have exactly the same slope, they'll never cross. Let's check the one on the right. So in pink, I'm going to go between the dots I drew, so I have to go down 2/1, so my slope is -2/1. For blue, I have to go down 1, 2, 3, and over 1, so my slope is -3/1. They're close, but they're not exactly the same, so these would not be parallel. Okay, another thing you want to be able to do is to recognize parallel lines from two sets of points. So now instead of telling you equations or giving you a graph, I'm just picking points off the lines. So here, really all you need to do is calculate the slope of each line. So I'm going to start with line A. And you can find the slope however you want. You could do the bar method, you could use y2 minus y1 over x2 minus x1. I'm going to do it both ways. So if I do y2 minus y1 over x2 minus x1, it's call this x1, y1, and then x2, y2. So my equation looks like 6 minus 2 over 1 minus 0, or 4 over 1. So my slope of line A I can simplify to 4. Oops, that's a little messy. Okay, now let's look at line B. I'm going to rewrite the points here. I'm going through -2, -11, and -3, -15. We use the bar method this time. Notice my arrows go the same way, so my slope would be change in y over change in x. Just another way to think about slope. To get from -11 to -15, I have to go down 4. To get from -2 to -3, I have to go down 1. -4 divided by -1 is 4. So now I can go back and double check. My slopes both are 4. They're exactly the same. So these would be parallel. Okay. We also need to be able to write equations and then graph them. So this one says this line contains -4, 2, and it's parallel to the line that passes through 0, -3, and 4, -2. So these points here are of the first line that already exists, and it's saying that this new line will be parallel to this line here. So I need to find the slope between these 2 points first. So I'm going to do the bar method again. So to get from, make sure you do change in y on top, -3 to -2, I'd have to add 1, and then 0 to 4 is 4. So my slope is 1/4, and I want to be parallel to this line. So if I want to be parallel to this line, my slope has to stay the same. So I'm going to use this slope again. But I know now that this new line needs to go through this point, -4, 2. So to write an equation for this line, I have a slope and I have a point. So I'm going to use point slope form. We think back to the other day, y minus y1 is equal to m times x minus x1. I'm going to plug in what I have. So this would be my x1, y1. So I'm going to have y minus 2 is equal to 1/4 x, and that's going to be turned into a plus 4 since it's negative. Now we talked about graphing in point slope form, and we talked about just changing this into slope intercept form. So to do that, I need to distribute first. So I get y minus 2 is equal to 1/4 x, so that's 1/4 times x, and then 1/4 times 4 would give me 1. And then I need to add 2. So my final equation is y is equal to 1/4 x plus 3. And now I can graph that. So I'm going to do my y-intercept first, is at 3, and then my slope says to go up 1 over 4. I'm going to go down 1, back 4, and then I have a nice line I can draw in. And we are done. Okay, one more example. So now this is similar to our previous one. I'm telling you I want to be parallel to the line y equals 3x minus 7, but now I want this new line to go through the point 4, -5. First thing is figuring out what the slope of my new line needs to be. So if this is my original slope, I know m is equal to 3, I can see it right there, and I know I'm going to be parallel, my slope stays the same. So I don't have to change anything there. I also know I want it to go through 4, -5. So again, I have a point, this point, and I have a slope. So I'm going to put it in point slope form. Y minus y1 is equal to m times x minus x1. And I'm going to plug in what I have. So 4, -5 is my x1, y1, and then I have my slope here. So I have y minus a -5 is equal to 3 times x minus 4. So this is going to turn into a plus. Now at this point I haven't said that you have to graph it, so you could leave the equation like this. Y plus 5 is equal to 3 times x minus 4. You could leave it like that since I didn't say you had to graph it. If you did want to graph it, then you would go through the steps of distributing. So just so you can see what it looks like, I get y plus 5 is equal to 3x minus 12. And then I would subtract 5. So I would have y is equal to 3x minus 17. So those are the same, or this is for the same line, just two different equations. So you are now an expert on parallel lines. You will be learning about perpendicular lines soon from your partner. So the key thing to remember is when you have two lines, they can be parallel, which you just learned about. They can be perpendicular, which your partner will teach you about. Or if it doesn't work out for either of those things, then they might be neither. So at this point, if your partner is not done yet, go ahead and try the practice review problems on your worksheet until they are ready to move on.